Welcome everybody in the lecture hall, welcome everybody on Zoom, welcome everybody from the future. Today we are going to finish the part on syntax. I have just a few slides left, but actually it's mostly because I redid the slides. So I'm never completely satisfied. I'm only satisfied if everybody understands. So initially, I talked about namespaces without really anticipating too much on what we will see in 2 weeks. In 2 weeks, we will see that you can define structures on top of XML and JSON, and then enforce constraints. And in fact, this is when namespaces actually start making sense. So I didn't want to anticipate on this, but now I realize that it might actually be useful to say a bit on this. So I will do it like this. So I completely redid these slides, should normally be re-uploaded. Is everything fine on Zoom? You can hear me? Yep, awesome. So, waiting for this little toolbar to disappear in the lecture hall. It's not disappearing, I think. Oh yeah, now it is. Okay, so the idea is that XML is all over the place, so is JSON actually, and it's used for many things. So it's used for web pages, even though for web pages, there's two syntaxes. There's the XML one and the regular HTML one. We have MathML for mathematical formulas. It's like LaTeX, but written in XML. So this is, you recognize the equation? Schrödinger. So you can do this with MathML. You can use it to encode music sheets, like all the notes and the rhythm and so on. I told you it's also like the when you file your tax declaration, that's all XML as well, and there are also constraints. And so basically, there's probably millions of them across the world. Everybody just enforces their constraints. There is usually an association, a standardization body, the governments, the companies, and say that they can all create constraints. What has established itself is that typically, in order to not create a big mess, they use namespaces and use their domain. So you're supposed to use a namespace with a domain you own. For example, the Swiss e-government standard, it's ech.ch. And so this is, they use namespaces that start with that. XHTML and MathML, they start with w3.org, which is the domain of the World Wide Web Consortium, co-founded by Tim Berners-Lee, with the web. So this is how it works. And so the idea is that they have namespaces like this. So I'm showing you a few examples. This is the namespace of XHTML. This is the one of MathML, Music XML, Swiss e-governments. This is just one of them. There's actually many, many of them. You can go to the website and see for yourself. What's important is that these namespaces are not really meant to be put in a browser address bar. This is not the goal, right? They are just resource identifiers, and they identify some constraints that you might have in XML. Very often, though, the people who do this are kind enough to put a page at the location in case you tap it in your browser. Sometimes you do have some landing page that says, for your information, you just type the namespace of some constraints and so on, but not always. So you might also get a 404. Okay, and so the idea is that once they have done that, you need to slightly modify your XML file in order to clarify that all the elements in there are in a namespace. Like in that case, it's MathML. The way you do it with a prefix that here we called M that is tied to the namespace, but I put a Python example because I think it's easier to understand it like this. It's exactly when you import, you do pip install and so on. Then you import a module as something like pandas as PD, numpy as NP, and this would be the prefix. This is when you use what you use in the Python code when you refer to the functions. Who's already seen this, right? Many of you. It's the same thing here. We just say, okay, import this horrible thing as M, and then you use M everywhere with a colon, right? Everybody with me? Now something magical happens. When you do that, normally, there's a mechanism in effect. It will check that the structure, in that case of your formula, is correct. So if you try to put the elements in a way that don't make sense, it will throw an error and not actually accept it. This is called validation. We'll see it in 2 weeks. So this is why once you add the namespace, this is actually going to kick in, all of that mechanism of validation. Now, I told you about default namespaces, and again, it's so much easier to understand in the context of Python. If you have a default namespace instead of the M, it's exactly the same thing, but it would basically be in Python if instead you say from pandas import star, and then you directly use the names of the functions. Who did that already? right? Some of you, it's the same thing. So it doesn't matter in Python if you say import pandas as PD or from pandas import star, it just modifies the way your code looks like, but it's the same effect. You're importing functions and you're using them. So just the same way that, again, in Python, it doesn't matter which prefix or alias you are going to use for your module. Any of that is exactly the same thing. The same goes here. It doesn't matter what you call the prefix that you bind it with. For whom does that make sense? All right, perfect. So now this is a concrete example that mixes two namespaces. This is in fact a web page because you see this is HTML and it's in the, you see that HTML, the prefix is in the XHTML namespace. So it's as if in Python, I was importing basically pandas and numpy, right? So I'm importing XHTML and mathml, and I'm giving the alias or the prefix HTML and math. And now I nicely colored in blue all of that has the HTML colon and all of that has the math colon. So all of that is mathml, that would be a mathematical formula, and all of that is HTML. You recognize body, H1P, this is all HTML, right? It is exactly the same as having pandas and numpy, and then you have pd.something or np.something when you refer to them. For whom is that clear? Right? I hope it's easier to understand than last week. This actually works. You can take that, copy paste it, put it in a .xhtml file, open it on your browser, and you will see what's on the top right. And you see the formula beautifully displayed because you used the mathml namespace. Right? So that is the XML syntax. The HTML syntax might be different and doesn't have namespaces, but this is the XML syntax. For whom does that make sense? All right, beautiful. So this is the beauty of namespaces. And now it's easy to create a huge mess with namespaces because it's actually very complicated. So this is why I'm only giving you specific patterns. The first pattern is no namespaces at all. It's when you don't even bother to have anything in a namespace. It's like writing a Python code with functions that you don't put in any modules, right? But as soon as you try to release some software and release a product and enforce constraint, then you should put somewhere in a namespace. So this is the default namespace. So that's what you use with from pandas import star, right? And this is with one prefix namespace. This is the import pandas as PD, right? So this is equivalent, the two are equivalent, okay? And then finally, you have when you have multiple namespaces, just like you import multiple modules in Python, here I put 4 of them, and this is it. Note that this, and this corresponds exactly to this, and this, right? This is not new, I'm just saying you the 4. Do not do anything else than that. You can do something different, like this. This is a huge mess. Don't do that. Nobody will understand it. It's hard to read. It's hard to parse. It's hard to figure out what belongs to where. So this is an absolutely big no. Just stick to that. Clean, tidy, and yeah. Okay. All right. So now there is a piece of software that would be nice if you could download from the IT shop. It's itshop.ethz.ch, right? You already had software. It's called Oxygen. Oxygen is an editor that has a lot of functionality related to XML, JSON schema, XML schema, and so on. It's very convenient when you want to open data sets or look at data or curate it or fix it and so on. So it can even be useful, not just for this course, but also for your projects, right? If you have semester projects or master projects that involve that kind of data. The good news is that ETH was kind enough to purchase a site license for everybody at ETH. So it means you can just have it for free as a student. So please go there and download it, and you will use it in the exercises, right? Don't have to do it now, but at a later point. And the sort of things you can do is try to open a document that has well-formedness issues, right? Remember, well-formedness means it doesn't parse as XML. There's mistakes. And if I give you an example here that has a lot of mistakes, for example, I directly give it, but typical mistakes is mismatching case, right? Big M, small m for the same element, so that doesn't work. Here, somebody used something that started with XML. Here, you have twice the same attributes name in the same element. That's not allowed. Here you have this forbidden smaller than that is unescaped. That's also not okay. Here you have an escaping that is not one of the 5. It has to be one of the 5. That would work in HTML, but not in XML. Here you have unquoted attributes. Here you have a comment that has a double dash that has nothing to do with this. And here you have somebody who copy-pasted probably the document from somewhere. And of course, it automatically enhanced the quotes to these fancy quotes. But the problem is that they are no longer recognizable as quotes, right? So the nice thing is that if you put that in Oxygen, it will tell you, like any XML editor, that's the beauty of standards. And it will help you fix them, show you the errors, just like when you have compile errors. And then you can fix it. And once you have done it, it even beautifully syntax highlights the document, right? So this is the idea. By the way, just so you're not scared, that here is not part of the course material. It just happens to be that you can also define your own codes like this, but this is absolutely not part of the material. That's what I said is a bit obsolete now with the DTDs, because we'll see schemas instead in 2 weeks, not DTDs. All right, so that's what I wanted to show you about XML. Hopefully now it's clearer what namespaces are for and why they are useful to basically scale the infrastructure worldwide. In terms of wrap-up, I wanted to link it back to the normal forms. So this, for example, is a table that has rows, and every row can be expressed in XML in this way. JSON, I showed you last week, right? But now XML. So the idea is that you can use elements for every one of the columns, right? So there's 4 columns, so you can put 4 elements, and then you can wrap it up in a parent element that has the name of the table, but typically in the singular, right? Because this is one row of the table, right? So you have a parent element and then the children element, and they have just text inside. Who sees that this is basically a representation in XML of that row, right? Okay. And then when you have multiple rows, so if you want the entire data set, what happens, and again, this is the convention, we put all of these sale elements, so there is 1 per row, we just put them one after the other inside another parent element that typically uses the plural form, right? So the plural form would be the entire table, and then the singular form is the name of each one of the elements. You see that they repeat, right? It's unlike keys in JSON. In XML, you can repeat. So typically, you have sale, as many as rows, and they are nicely nested inside the sales elements. And so once you add namespaces to it, but that we'll see in 2 weeks, you can actually have a schema that enforces that sale has a product, a price that is an integer, a customer that is a string, a quantity that is an integer, and that will throw an error if it doesn't. But again, we'll see that in 2 weeks, okay? So this is the reason why it's always called sale, because the name that you give to an element is what ties to the validation constraints. For whom is that clear? Right? So then we get the same benefits as in a relational table when you can actually enforce the structure. So this is another example, but what I did here is it's the same as here, except that I indented it nicely, but this is only for readability by a human. That actually is totally irrelevant to XML, but human beings like to see these nice indentations. Oxygen can also do it for you. If you downloaded an XML file, it's all on the same line. You have a shortcut. I think it's Apple Shift P or something on macOS. There's probably one on Windows. And it automatically pretty-prints the XML, adding the spaces and the indentation and new lines to make it look nice, like this. Okay, so this is one other benefit when you want to discover a data set that you just downloaded from the internet and you want to see what it looks like. What about nested data? Well, in JSON, I showed you this is done with arrays that have objects, right? With arrays of objects that are inside the bigger object. In XML, we just nest elements. So let's look in details here. We have the sales table. I just have 1 row, but you can imagine other rows. So the sales table, this is 1 row, sale in singular. It has product, price, and orders, right? This is why it's nested. Inside that should be table. I don't know why I forgot to fix it. I should put table in there. Somebody objected. So orders. And then what happens is that because it's nested, inside these orders that goes all the way to here, we again nest order, 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 just like in the British Parliament, right? So the idea is that you have 1 row here, 1 row here, and 1 row here, and you just nicely put them one after the other. Okay? Who is with me? right? So this is how you get nestedness in XML and in JSON, and you don't get it in CSV. Now, if you want to troll internet forums, just pick a polarizing topic like, is XML better than JSON? And then you'll get millions of replies like, no, JSON is better, no, XML is better, and so on. Do not fall for it. As a computer scientist, you need to look at every use case. There are use cases in which XML is actually good, especially in the publishing industry or in government standards. And there are other use cases in which JSON might be actually a better alternative because we'll see in 2 weeks it's closer to data frames and tables. All right. And furthermore, there's not the only two in town. These are not the only two in town. There's other syntaxes. One of them is YAML. So whenever you have something that starts with yet, YA, it's yet another, right? Yet another markup language, YAML. It's gaining in popularity. I think it's very popular with Kubernetes. Who already saw that in Kubernetes, right? Many of you. So if you look at it, actually, I don't even need to teach it to you. You probably already see it. Who sees the object structures and the array structures here without even me telling you anything? Do you see them? Right? Many of you. See? You have here an array. It's a list. And you have here an object. And you have here an object. So you see, you can have exactly the same kind of structures as in XML and JSON. And so maybe some other syntaxes will start appearing later. The convenience here is that compared to JSON, if as a human you want to edit the file, it's a bit easier because with JSON, you need to match the curly braces and the square brackets. But in YAML, you don't need to worry about that. If you want to add something, you just add a new line and so on. So it's a bit quicker to edit, right? But in the end, it doesn't matter. We'll see in 2 weeks, we have data models. We'll basically see all of these as trees, denormalized tables, and we'll see that it doesn't really matter which one we use, because in the end, from a modeling perspective, from a data modeling perspective, these are really just collections of trees, all of them. Okay, do we have any questions? Yes?
Like, could you suggest or give an example when it's better to use XML and when JSON?
Yep, absolutely. There is one use case that is the most commonly cited as something that JSON cannot do well, is when you have papers or books or documents that basically contain text, a flow of text that is annotated. Like this is a section, this is a chapter, this is a paragraph, and so on. This has this style, this has that style. This is much easier to do and more natural to do in XML than in JSON, right? So in JSON, if you have data sets, it's very natural to do. But if you try as an exercise to take, like DocBook is one of the standards in XML to have text. If you try to do it in JSON, you will see that it's less natural and that it's very cumbersome. You could, of course, because it's always possible, but you will see that it's more cumbersome to do, right? Because in XML, when you have text, I mean, anybody who already wrote by hand HTML pages, right? It's exactly that experience. If you use XML for publishing and for text, it's exactly like this. You write the text, then you add the tags all over the place to format it. So this is one, perhaps the most prominent use case for using XML that is preferable to JSON. Another one is for the government standards, but here the reason is different because technically you could also do the government standards in JSON. It would work as well. But the reason why the governments typically prefer XML is because of the maturity of the ecosystem. They basically rely on 20 years of standardization of XML schema and so on. And you have a lot of enterprise-ready tools that perfectly work today and that are highly reliable. It might be that in 10 years, JSON catches up a bit more and that we have the same level of maturity, and then you could absolutely consider using JSON, right? Did it answer your question? Yeah, awesome. Any other questions? On Zoom? Nobody? Okay. So again, the take-home message here is if we denormalize tables, we get trees. CSV cannot do that. CSV can only do tables, so we need other kinds of syntaxes. And this is why we have XML, JSON, YAML, and all the others. All right, so now I'll move on. So let me stop the recording and see you on the other side.